Welcome to Mrs. Taylor's math class. Today, I would like for you to practice with me solving literal equations. Now let's begin class. Here are your 6 problems. Pause the video. For question 1, we need to solve for x, which is right here. So I'm going to subtract b first because it's not attached to the x. And so we have ax is equal to c minus b. And then we are going to divide both sides by a. And x is equal to c minus b over a. And you're done. For question number 2, we need to solve for t. So we could treat this like a cross multiplication. And so you could say 1 times d is d, and r times t is rt. And to solve for t, you just divide both sides by r, and you're back to d over r is equal to t, or you can write it as t equals d over r. And you're done. Either one works. For question 3, you need to solve for x. So again, this is a fraction on the left side. Make this side a fraction as well. And so you can cross multiply, and you get CD is equal to 1 times this entire expression, which is going to be that expression, ax plus b. And so you're solving for x, so let's subtract the b from both sides. And we're left with CD minus b is equal to ax. And then divide both sides by a. And we're left with CD minus b over a is equal to x. And you're done. For question number 4, you want to solve for the letter P. And so because this is P times whatever's in the parentheses, it's really only one step. So you're going to divide both sides by all the items that are inside the parentheses, because they work as like a package deal. They all move together. So this cancels out, and so you're left with P is equal to A 1 plus RT, and we're done. For question 5, this one looks very intimidating because it's kind of long, but you're just solving for the letter V, which is here. So everything else is just separated by a plus sign. So all you got to do is do the opposite of addition, which is subtraction. So we're going to subtract the UT. We're going to subtract the 1/2 AT squared, but not this item here. We're going to do something different there. So when we do that, we're left with S minus UT minus 1/2 AT squared, which is equal to VT. Now, that is V times T, do the opposite of multiplication, which is division. And so all of this is going to be divided by T. And so now you're done. V is equal to S minus UT minus 1/2 AT squared all over T. So that just looked intimidating, but it only took 2 steps and we're done. For question number 6, there are several ways to do this problem. But what I'm going to do is I'm going to get rid of the fraction because most people don't like dealing with the fraction. So I'm going to do the method where you clear the fraction first. So you see all my denominators, x, y, z. I'm going to multiply each one of the fractions by x, y, z. And what's going to happen is that whatever letters in your denominator end up getting eliminated, and you're left with the other 2 letters. So for the first one, the x is eliminated, and I'm left with yz. For the second term, the y is in the denominator, so I'm left with xz. And for the last term, z is in your denominator, so you're left with xy. And just like that, your denominators, your fractions are gone. So you know you have to solve for x. So let's take this xz over with the xy by subtracting it. And we get yz is equal to xy minus xz. Let's factor out the x, and you're left with y minus z. And so let's divide both sides by y minus z, because it's all in parentheses like a package deal. And your answer is x is equal to yz over y minus z. And you are done. Thanks for watching. Don't forget to like, comment, share, and subscribe. Class is dismissed.